So we will be taking notes on the foldable that you just received, and on the outside it says sine and cosine, or sine versus cosine, and afterwards we're going to do like a trifold with it, but we're just going to be filling in on the inside. And so I want you guys to pause the video and kind of do this on your own, and then play it again and see what the answers are. You know, the first two examples, you guys already know how to do all of this. So take a second, pause, and work through example 1. And when you guys finish, then play the video again and see what we get. So you should have gotten that the sine of C is 24 over 25. If we're looking from C, opposite is 24, and then 25 is hypotenuse. And then the cosine of C is adjacent over hypotenuse, and adjacent is 7. Hypotenuse is the same as 25. Now, when we switch and look from angle T, you should get that sine of T is 7 over 25. We're doing opposite over hypotenuse. And then cosine of T is 24 over 25, and that's because we're doing adjacent over hypotenuse. And I want you to see if you notice something about sine and cosine when we switch from one non-right angle to the other non-right angle. We only have 2 angles in the triangle that are not right, and I just want to see if you pick up on what's happening as we go through these. You should have solved for the angles. And you do that by basically taking the function you already set up. I started with t, but I'll go back to c. And then taking the sine inverse of both sides. And if we look at our table, or we put that in the calculator, then we get 16.26 degrees. Now, if I do the same thing for angle C, I decided to use cosine on this one. So I cosine inverse each side, and I get 73.74. Okay, now you should be pausing the video again and going through example 2. Okay, so now to check your work for example 2, you should have gotten that sine of D. We have opposite over hypotenuse, so that's 16.58 over 18. And cosine of D, which is adjacent over hypotenuse, is 7 over 18. So then for angle G, sine is now 7 over 18, opposite over hypotenuse. And cosine is adjacent over hypotenuse, which is 16.58 over 18. Now when we use our inverse functions to get the angle, just taking the cosine ratio for angle D, I could have chose either one. We should get the same answer. And we get that D is 67.11 degrees. And when we figure out angle G, I decided to use the sine one. We could use either or, but we end up getting that G is 22.89. So now the point of this is to observe the relationship that sine and cosine have. So I want you to look at the relationship that angle C and angle T have right now. We have that C is 73.74 and T is 16.26. And if you notice, all angles of a triangle add up to 180. And we already have a 90-degree angle, so the other 2 angles must add up to 90, and we call this complementary. We've gone over that before. So these are complementary angles, and this is the same for D and G. These are both complementary as well. They add up to 90. So when we compare the sine and cosine ratios for the angles in each example, what can we conclude about sine and cosine of the non-right angles of a right triangle? And you should notice that, like sine of C, which was 24 over 25, is equal to cosine of T. And then, vice versa, sine of Just trying to change my highlighter color if I can. Sine of t, which is 7 over 25, is equal to cosine of c, which is 7 over 25. And then we have that occurring on the second example too. Sine of d is equal to cosine of g, and cosine of d is equal to sine of g. So basically the cosine and sine ratios are equal for complementary angles. So the way we would write that out is that sine of theta, so any angle, will equal cosine of 90 minus theta, or whatever the second angle is. And then similarly, cosine of theta will equal sine of 90 minus theta. Just taking whatever that angle is and figuring out that the other angle is found by subtracting one angle from 90, and that these two sine and cosine ratios will be the same. And what we call this, the relationship between sine and cosine, is that they are co-functions. So sine and cosine are co-functions. And really all you need to be able to recognize is that these ratios are the same when we switch angles. And when you guys do your choice board today and you pick your own examples, numbers, where did I put mine? Numbers 7, 8, 9, 10, and 11 use this relationship between cosine and sine. So on 7, 8, and 9, you should be able to find, just what the angle is, but on 10 and 11, it's a little more difficult, and we have to work it out algebraically. And I know that some of you guys can do that. And also use your table to kind of help you with these relationships to figure out when sine and cosine are equal, when they're going to be the same every time. It has to be when the legs are the same. So think about what angles we have when our two legs of the triangle are the same. That's one of our special right triangles. So that's going to be an instance when sine and cosine are actually the same and they don't just switch for each angle. It's got to be because the angles are the same and the legs are the same. So I want you guys to use this as you go through the choice board. You can choose, the point value is off to the side of each question, and you're just going to choose questions that will add up to 100 points. So you kind of get to make your own choice in what problems you do. And make sure that you have these done for Tuesday.